All right. Thank you, Camille, and good morning, everyone. It's nice to see you all, and I really appreciated our keynote speaker, Stacy Mahler's overview. I think it's very consistent with what we're trying to do in the College of Engineering. We are, as you all know, engineers design and build our future, and so that means we have the opportunity to shape our future to be hopefully more equitable, as well as more sustainable and healthy and joyful for all. So as Camille mentioned, in the College of Engineering, yes, recently we've started a new Center for Smart Infrastructure, and this will be the topic of the fireside chat with Sashi in a few minutes. So as we have seen, information and communication technology, big data, Internet of Things, cloud computing has really caused a digital transformation of every aspect of life in modern society. And as we can monitor and collect data about pretty much anything, this gives us the opportunity to monitor how we use energy and how we consume, and how we monitor our infrastructure so that we can ensure that it's resilient. And I think this field has all kinds of opportunities for diversity of talent. We definitely need a diversity of perspectives to ensure that the new devices and technologies we create today will be beneficial for all and ensure a sustainable future for all. So I look forward to the fireside chat with Sashi, but I know there are some students and faculty here from the College of Engineering who are very interested to gain insights from our speakers today. And so I thank the organizers of the symposium for lining up a good set of speakers and panelists.
That's great. Thank you, Sujay. I was just going to ask, I'm glad that you brought in the diversity question. I was wondering, as you observe enrollment and interest in some of these, say, civil engineering or other kind of infrastructure engineering programs, if you see greater diversity there, perhaps than in other subfields of engineering.
Yes, actually, environmental engineering is one of the more almost gender balanced fields of subfields of engineering today. And information technology, we definitely need to make more progress. But I think if women who are interested in helping to shape a better future realize that there are a lot of opportunities in electrical and computer engineering to develop technologies that will be used by environmental engineers and structural engineers, civil engineers, to ensure a more resilient future. I think that vision can help to attract a greater diversity of talent to other subfields of engineering, which, as Stacy mentioned, it requires everyone from across all these disciplines to work together, to collaborate, and to persist, so that we can hopefully stem global this climate change and make it more equitable. Right? We know today urban infrastructure is actually exacerbating inequities. How can we change that? Well, we need to bring people together to discuss, illuminate the reasons for these inequities, and to find solutions together to solve them.
Yeah, thank you. That interdisciplinarity is really important, and that's a way that we're going to find sustainable solutions and new and creative solutions. So I'm glad that Berkeley Engineering is a leader in that area. And of course, that is a specialty for CITRIS as well. We like to be Absolutely. Interdisciplinary and have that application for the impact on society in the projects that we support. So I see that Sashi is on the line now, so I will go ahead and ask her to turn her video on and introduce both of you. We're really delighted to have you here for a fireside chat. Sashi Obelisetti is Group Director of R&D in the Electronic Design Automation Group at Synopsys. As a respected leader with broad technical expertise in her 12 plus years at Synopsys, Sashi has been instrumental in enabling several Synopsys technologies in design, verification, and post-silicon stages. She's an innovative thinker capable of bringing new technologies into established teams. She was one of the key leaders involved in ushering AI usage into Synopsys products. In previous roles, she was the chief architect for Silicon Solutions at Google Cloud, where she was responsible for building strategic solutions to enable design on cloud using Google Cloud technologies. And she's also the founder of 2 startups. So welcome, Sashi. Sujay, I'll just introduce you briefly. Dean and Roy W. Carlson Professor of Engineering, internationally recognized for your innovations in semiconductor technology and highly regarded for your achievements as an instructor, mentor, and administrator. Sujay's technical contributions, over 550 publications and 96 US patents, have enabled the semiconductor industry to continually improve the performance of leading-edge microchips. Sujay is Dean of UC Berkeley's College of Engineering, the top-ranked public school of engineering in the US, and a member of the board of directors for Intel Corporation. Both organizations value excellence, ethical behavior, equity and inclusion, and aim to enrich the lives of all people on our planet. Please join me in welcoming Sujay and Sashi.
Thank you, Camille, for that really generous, kind introduction. And thank you, Sashi, for joining me today for a chat to explore the role of smart infrastructure and technologies in creating a more resilient and equitable future for all. So I'd like to start with some questions and then before opening it up to the audience for Q&A. So to start, what is smart tech to you, Sashi, and why is this an important area for us to focus on now?
Thank you, Sujay, and thank you, Berkeley and Bernard Tower Institute for inviting me. So smart tech to me is actually about automation, opportunity, and a safer world. So let me maybe elaborate a little bit on this. I think it is about automation because SMART actually is an acronym. I recently found out that it is about, the acronym stands for self-monitoring, analysis, and reporting technology. So that's what SMART is. And it's about automating and making things smarter. And that is actually something that happens with a lot of use of technologies. We use electronics for that. We use AI for that. But it's all about automation. And that helps make things better. I say it is about opportunity because to make things smart and to automate, there is a lot of work involved. There's a lot of new jobs. There's a lot of opportunity. We have this role called data scientist, which was not there a few years back. So that's where the opportunity and new jobs and new roles come up. And finally, about a safer, more environment-friendly place, and that's where we have smarter cities. We turn off lights when it is daylight. A lot of automation actually, that's a small example, but they're much bigger example where we even save lives by using smart tech. So it's really about a combination of automation, opportunity, and a safer world.
Thanks. Now you talked about or alluded to microchips. What do semiconductors have to do with smart tech, and why do they matter?
That's my favorite topic. And I think semiconductors are, clearly front and center for some of the technologies that are driving smartphones, smart cars, smarter systems, and it's actually the foundation for some of the smart devices that we see out there, right? And now the question really comes: if semiconductors are driving some of the smart systems out there, what is going to drive the semiconductors to be more reliable, right? And that's like the second level, and that's actually ties in very well with the new opportunities and jobs that I talked about. Clearly, you can automate things by putting a CPU, a central processing unit, or a microcontroller, but those were already existing, right? We didn't do anything new there. We just brought them and we automated things. But now let's say that you have a medical equipment, which is very critical. We want to make sure that the semiconductors are reliable, right? And that's the that's the innovation that we are currently seeing in semiconductors that helps with building not just smarter systems, but smarter and reliable systems.
Makes good sense. So I'm just curious, what are the challenges for making chips more reliable that you see from your perspective?
I think as the chips become more and more complex, and Sujay, you know this a lot more than me, about Moore's law and how over the past multiple decades we have been making the chips more and more complex, doubling the number of transistors. What it means is that we are now seeing trillion transistor chips. That's amazing, right? So how do you actually observe what is going on inside a trillion transistor chip? We are not there where we can probe things. And traditional technologies where you can actually, create something that is called scan, where you can actually see what is happening inside the registers of a chip is not sufficient. You have to know what is happening inside the chip while the chip is in operation. And some of the innovations that we are seeing in this space is we insert sensors inside the chip while it is being designed. So think about it. You have to now build this process right when you're designing the chip. You have to make sure that the chip is observable. So therefore, you have to make sure that I put in like a temperature sensor or a voltage sensor all over the chip, or maybe on some paths inside the chip. So these are some innovations that we are seeing. Now, the interesting part about this technology is that your work doesn't end once you've inserted the sensors. You also have to bring that telemetry data outside, and then you have to build some analytics around it. And that's where the data science and that's where the front to back, the generation of data and the use of data comes in. And I want to apologize. I just noticed that my camera was set to somehow it happened. I think that's the end-to-end story, and this is the innovation that we are seeing.
Very interesting. So, of course, designing for reliable operation from the get-go.
Absolutely.
Yeah, I think it's interesting because in the past, like at the very leading edge of technology, or the chips that have the greatest complexity, the most number of transistors integrated on a single die, they've been designed primarily for achieving the best performance, computing power, and for those applications, the industry would assume that as with new generations of chips coming out, that these chips the computing chips would be updated or replaced. But for a lot of applications now, for smart tech, automated and resilient infrastructure, those chips have to last for not a few years when you replace your laptop or your cell phone, but for decades. And so this is why we really need to think about designing these complex integrated circuits to be reliable, much more reliable than we've been doing so in the past. So
absolutely. And it is also tied to the technology node. And there was a time maybe when you were at the way we talk about semiconductors is higher number is actually low technology. So a 28 nanometer is a lower technology, is simpler technology, than a 5 nanometer, which is more complex technology, right? So a 28 nanometer chip would potentially last maybe 100 years, or like I like to say, at least until I retire. I'm not worried after that. But a 5 nanometer chip, it's a new technology, and we don't know, can it last for the 15 years that a car is in operation? We don't know that. So that's the complexity.
Yes, a lot of challenges. So with increasing digitalization of the world that we live in, you mentioned cars. So how does smart tech play a role in connected cars and smart cities?
I think of all the technologies that I have seen, connected cars seems to be a place where complex chips, AI, cloud, everything kind of comes together. And everybody knows about autonomous driving, autonomous driver assisted systems, and where we smarter chips play a huge role in that. There are chips right now which enable the image recognition and the self-driving technologies that are in place in cars, for instance. There is technology where we have telemetry data that comes from the cars to the car manufacturer, for instance, and they can predict the health of a car based on a certain signal that they are getting from the car. So it's about predictive maintenance. Even taking it to a higher level, I think the data that is generated from a smart car is helping cities manage traffic patterns, is helping insurance companies understand how to price their products. So I feel that these are just amazingly new markets, right? And I think actually the ability of a smart car to provide signals during driving makes it a safer experience, not just for the person who's driving the car, but also for the cars around you. So it's a combination of everything that I talked about. It's about automation. It's about a safer place. So I think it's a great example for what we see today. We've even started seeing that today, but I think we'll see a lot more of it in the future.
Wonderful. So again, automation will help us to hopefully direct traffic more efficiently and safely. So I think maybe some of the people in the audience might be thinking, well, if cars are communicating information all the time, one of the unintended consequences would be lack of privacy or security of information. So what are other such unintended consequences of smart tech, and how can greater representation in this field help to overcome to avoid these hopefully unintended negative consequences?
I think that's a good question, Sujay. And I think I would qualify it as a learning process for us. I mean, we are making progress. There's of course, whenever there's data, there is the question about privacy, right? And there are regulations in place where the data is anonymized and then transported. But I also think this is the place where more diversity kind of helps in the design of better products, right? And I think by bringing a diverse workforce to build supporting products helps in a design and a delivery of products that help a wider customer base. right? So I think that's the way I feel broadening the space and including diverse talent in the space will help us actually provide a much better coverage of the products that are available now, as well as, we don't know what we don't know, right? That's the way I like to think about it. But by bringing a diverse talent into the space, I'm sure that we can solve problems that we don't even know exist at this point, and that's a necessity. Otherwise, we are only supporting the problems that we know at this point.
That's a good point. So, how do we attract a greater diversity of talent to smart tech? Maybe you can share how your own career path, how you got into.
I think my career path was fairly routine, I would say, till a certain point. I grew up in India. I studied engineering, probably mostly because my dad was an engineer, my brother was an engineer, my uncles were engineers. So I studied in a pretty good university in India, and this was a few decades back. And I really wanted to pursue graduate study. So I studied electronics and communication engineering, and then I came to the US to do a master's. I came to UMass Amherst. So and I studied computer engineering. And my introduction to what I call electronic design automation, if I had to give a 10,000 feet overview, you design hardware just like you design software for most purposes. Just like how you write Java or C and you create software, you also design hardware using high-level description language. And there are these tools, this industry called electronic design automation, where we build tools that take this high-level description language and creates those chips that we talked about. So my introduction to electronic design automation happened during my graduate years. So I think purely by chance, maybe because I was doing computer engineering. And I worked at a startup, which was incredibly valuable to me to learn about, just right out of my first job was in a startup. It helped me understand, or maybe it helped me understand how a company works. With a startup, you get to see that. So soon after the startup, very early on in my career, I actually founded 2 companies in the electronic design automation space, and that helped me navigate the industry a lot better. I joined Synopsys after that. I've been with Synopsys for quite some time now. And this is where I was exposed to a lot more technologies supporting electronic design automation. I was instrumental in starting the AI team in Synopsys. This was in 2014, and kind of bringing more and more AI and ML technologies in EDA. Now, of course, almost every EDA tool has an AI engine, but that wasn't the case because EDA was at least 40, 50 years old, right? And then I think I for a very brief time, I was at Google Cloud, but I rejoined Synopsys. But the Google Cloud experience was valuable in terms of learning about how the cloud works, how cloud brings elasticity, better machines, and just sort of is a necessity when we are talking about building big systems. So now I'm back at Synopsys and very closely involved in enabling smart systems. We call it Silicon Lifecycle Management, or SLM. The idea here is that silicon has a life cycle. It's not just the design of silicon, but there's a design phase, there's a manufacturing phase, and then there is a deployment or a mission mode phase. So my role now is to enable the creation of SLM-enabled systems, and I love it.
Thank you for sharing your career pathway. It looks like we have a few questions, so why don't we move to those? Maybe, well, I'll just, they're listed in sequence here. I'm not sure, maybe time sequence. So Akin Oyalakin is asking you, what are the current research gaps for semiconductor development from your perspective?
So I think in semiconductors, there is always, as you, the research area in semiconductors is very strong. In fact, how do you make sure that it's a very complex problem, right? You have to meet your timing. You have to make sure that your power is within the power budget. So there is always research going on in physical synthesis, which is a standard area. But the other area that is very big also is on how do you apply AI and come up with the design of a chip faster than before. The chip design process takes a long time, and people always want to shrink that time. So there is a lot of research that is possible in the space of AI as applied to chip design. In fact, there are many companies that are engaged in this. But let's also not forget the traditional process. How do you make chips more reliable? How do you make the chips more secure? Those are also very key research areas at this point.
Great. Okay. And the follow-up question is, do you, I suppose that means Synopsys, actually fund research, semiconductor research?
We have an organization called SERA, which is very active in enabling research, both via a grant of our tools to universities. Clearly Synopsys tools are being used in every chip that is manufactured, right? So we do have a very well-oiled process where we work with universities. There's an organization that works on enabling universities and research. In addition to that, I also want to highlight that Synopsys has a very strong intern program. And this is a great opportunity for folks to work with Synopsys engineers who are engaged in either our synthesis products or our test products, our manufacturing products, so that there is that opportunity as well.
Okay, so we touched upon this. Well, actually, there's a good question from Gavin Dodds. How secure is the future of semiconductors, seeing that over 90% of it comes from Taiwan? This is the leading edge semiconductor chips.
Yeah, so I think one of the side benefits of the chip shortage is that everybody now has a really good knowledge about chips in general. So it is true that a lot of the chips are manufactured in Taiwan. One of the TSMC is one of the biggest foundries. But let's also take a step back and understand that the design of chips is a very complicated process, right? And long back, a few years back, like maybe 50 years back, companies like NVIDIA and AMD and Qualcomm, these are the names that we think about, right? When we think about chips, they actually don't have their fabrication facilities. They work with the foundries out there, like, most of them, some of them in Taiwan. Samsung is a big foundry in Korea. So while the chips are manufactured outside, it doesn't mean that the companies that are building chips, some of them in the US, don't play a part. They play a huge part. The manufacturing is maybe focused in countries outside, but I believe that this is a problem that is being addressed. Last year, the Congress passed a huge bill here, and we are trying to bring back some of the manufacturing. There are some new plants being put by the Intel Foundry team as well. Some other investments by some of the foundries in US is also happening. So I believe this is something that is going to balance out a little bit in the future.
Yeah, it's a good
so
point.
I think it is very safe. In fact, I like to say that we are at the beginning of smart technology.
Yeah, so it's very timely. Just yesterday, the notice of a funding opportunity came out from the Department of Commerce. So this is for $39 billion of funding, incentives for companies to manufacture chips here in the U.S. And that covers leading edge as well as more mature manufacturing processes for a wide range of chips, just to ensure a secure supply of chips for American companies and businesses and government. Okay, so Gavin also had this follow-up question. He wants to delve a little bit further, or Sashi, for you to delve further about protecting privacy in electronic design automation. So should we sacrifice privacy for convenience or comfort in this regard? Because smart tech definitely makes life more convenient and comfortable, but we give up privacy in some ways. So what do you think about that balance, that trade-off?
I think there is definitely a balance that needs to be agreed upon by the stakeholders. For instance, your car, right? You do need to get real-time information about the speed of the car, or where it is and how it is running, to actually provide you feedback on when you will reach your destination and things like that. And I believe, first of all, about privacy, it is about making sure that there is agreement that this data is being collected, right? So I think there has to be a balance in this, and we should leave it to the user to ensure that they are comfortable with the amount of data being shared, and provide that understanding that the services that you receive will be based on the data that you provide, right? But there has to be that agreement. Clearly, the data has to be stored and almost guarded by the end user here. Let's say it's the car company. They have to guard it, and it's not something that can be that is sold, for instance. I think this needs regulation. It would be it is almost necessary to bring the right team together to provide the regulation needed, so that the stakeholder interests are represented and addressed.
Good point. So regulation, and also making sure that the users are aware and agree to have their information shared. But this also drives the need for smarter tech or smarter devices at the edge. So let's say the car collecting the data can process it a little bit and convey only the information that the system needs to make a decision about what time you're going to arrive at the destination. So as much as possible, if we can do processing in these edge devices that, the sensors, including automobiles. So where data is collected, we process it to try to protect privacy and only transmit the information that is really needed to obtain the information that's needed to control or for the user.
Yeah, that's that. In fact, that is already happening to a certain level, and also driving the need for more powerful silicon devices at the edge.
Yeah, and this is actually also sustainability related to resilience issue, because if you have to transmit every single piece of data that your car collects through the cloud to some data center or something, that takes a lot of energy. And so if you just reduce the data to some minimum set of information to transmit, that saves time and energy. But this balance, I'd like to point out, can shift with time, and it also depends on the culture. So different countries have different people in different societies in different countries have different levels of tolerance for lack of privacy. So in my own experience, when I was working in the flat panel display industry decades ago, originally companies like AT&T and Bell Labs, they were supporting research and development of these miniature flat panel displays that are used in our cell phones and so on. But that failed because at that time, and they were thinking, well, wouldn't it be nice? At that time, people at home had their phones on the wall, or everybody had a landline, and company they were thinking, well, wouldn't it be nice to have people to be able to see the people you're talking to? Right? And that's why companies invested in developing information displays. But they found that there was no appetite for this. People were too worried. I don't want people to see me in my bathrobe with hair and curls. That wasn't even anyway. So the consumers did not want that, and so that's why those companies never went into the display business. But today, if you look at our cell phones, it seems like people don't really mind having people see you, even if you're not perfectly groomed and dressed in your business clothes before they talk to you. They see you on your phone, right? So I think people's preferences and values do evolve over time. Society evolves over time. So this balance is something that is dynamic, and all the more why we need a diversity of people to be involved in designing and implementing.
Absolutely, Sujay. You bring up a fantastic example here. This is why we need diversity, right? I mean, there's people from different cultures view things differently, and people with huge traffic congestion welcome self-driving, for instance, right? Yeah, absolutely. I completely agree with you there.
Okay. Thank you so much again, Sashi, for joining us this morning, sharing your perspectives, your insight on smart tech for a resilient future. And I wish you continued success in your career path. And I hope that our conversation has inspired members of the audience to consider careers in this industry. We need you, we need you all. We need the smartest people to develop smart tech for the future. That's my personal opinion. So I'm really happy to see all the people here who joined us, and look forward to a brighter future ahead. Thank you.
Thank you, Sujay. Thank you, everyone. Bye-bye.
Thank you both. Thank you, Sasha and Sashi and Sujay for such an engaging discussion. It was really wide-ranging and brought up a lot of implications. It was really inspiring to hear about your work with Synopsys and the developments and challenges for the semiconductor industry. I'm still trying to wrap my head around trillion transistors on a chip. And it's great to hear also about your career path. I think that'll be inspiring for many of the students who are on the call or in the symposium.